Hello and welcome to Unit 9. So I know this says 11, it should say 9. So today we're mostly going to be talking about combining like terms. So it shouldn't be a super difficult lesson, but there are going to be a couple new vocabulary words that you should know. So the first thing we're going to talk about is a monomial. So a monomial is just a number or a variable, or a number times a variable. So some examples of monomials, so like 5, that's just a number, it's a monomial. X, it's just a variable, it's a monomial. Negative 7xy, that's a monomial because we're not adding or subtracting anything. So a monomial is just one term with either one number, one variable, or a combination of the two being multiplied together. This would also be a monomial here because again, we're not adding or subtracting any terms. A binomial means that we are adding or subtracting two terms. Trinomial, 3 terms. When I say polynomial, that just means we have more than one term. So polynomial means we have more than one term. So sometimes we're going to be asked to find the degree of a polynomial. So notice that this is a polynomial in example 1 because there are 4 different terms. So the first thing we need to do is put it in standard form. So standard form means that we have all of our terms with the highest degree measure going first. So the highest exponent, I should say. So negative 7x to the 5th. The squared is next, so plus 4x squared, and then x. So plus 6x, and then plus 9. So this is standard form because the exponents are in order from greatest to least. So the degree measure is just whatever the highest exponent is. So in this case, it is 5, so this would be the 5th degree. So on this next one, we got to put in standard form. So I'm going to look for the biggest exponent, which is 5. Next biggest is 3, so plus 9x to the 3rd. And then next one is 2, so minus 4x squared and plus 16. So this highest exponent is 5, so that means, again, we have the 5th degree. So just as you perform operations numbers, you can perform operations on polynomials. So to add or subtract polynomials, we combine like terms. So this is something you should have already seen before, hopefully. So example 2 just tells us to simplify these things. So we got a p to the 3rd, p to the 3rd. This is a p to the 2nd. So I've squared, or I boxed the two like terms. So those I can combine. If I have 12p to the 3rds, and I add 8p to the 3rds, I have a total of 20p to the 3rds. P squared, there's no other like terms, so I have to just leave it the way it is. So this would be my final answer. So that is a binomial because there are two terms here. Second part of example 2. So we got an x squared and x. Those are not like terms, but I do have two numbers here. So I have a negative 6 and an 8. If they're just numbers, those are like terms. So I'm going to write the highest exponent first, so 5x squared, there's nothing to combine it with, so I just leave it the way it is. There's nothing to combine with the x, so minus 3x. Negative 6 plus 8 would be plus 2, so that'd be my answer right there. In example 3, we're doing more of the same thing, so we got a t squared minus a 4t squared. So 1 minus 4 would be negative 3, so negative 3t squared. And then I have a 2s squared minus s squared. So that'd be just 1s squared, or plus s squared. Then it gets a little trickier, so we got a m squared n, m squared n, m squared n. So these are all like terms because they have the same variables. The m is squared, the n has no exponent. So since they're the same variables, they're all like terms. So 10 plus 4 is 14, minus 8 is 6, so 6m squared n. So moving on to the next page. Again, combining like terms. So this time we have parentheses that are separated by an addition sign. So that means I'm adding the two sets of parentheses. So I look for like terms. X squared, x squared. So I got 5x squared plus 2x squared. So that's 7x squared. Then we got 4x, 5x. So 4x plus 5x. So that would be plus 9x. And then finally 1 plus 2, which we can all do, is 3. So that's our answer on the first part of example 4. Next, we got a plus sign in between the sets of parentheses. So that means I'm going to be adding the like terms. So 6x squared plus 3x squared minus 8x squared. So I got a 6 plus 3 is 9. 9 minus 8 is 1. So I'm left with 1x squared, or just x squared. Now I have a minus 4y and a plus 3y minus 2y. So negative 4y plus 3y, that's negative y. Negative y minus 2y would be minus 3y. I do not see any other terms, so that is our answer right there. So just a reminder here, if I have a negative on the outside of parentheses, if I distribute that negative, which is the first thing you should do, then it becomes negative 2x cubed plus 3x minus 7. So negative 2x cubed minus minus or plus 3x and then minus 7. So in example 5, this time we have a subtraction sign in between the two parentheses. So we're going to be subtracting. First thing I'm going to do is I'm going to distribute this negative sign. So x squared. As soon as I distribute, I can get rid of all the parentheses. So x cubed plus 4y minus 2x cubed. So I have an x cubed, negative 2x cubed. So 1 minus 2, that'd be negative 1, or negative x cubed. No like terms with the 4y, so that just stays the same. Example 6. So again, we have a subtraction sign in between the sets of parentheses. So first thing I want to do is distribute that subtraction sign. So when we distribute, the parentheses go away. So 7m to the 4th minus 2m squared minus 5m to the 4th minus minus 5m squared. When we have two minuses in a row, it turns into a plus. And then minus 8. So now I'm going to look for all the like terms. So I got a 7m to the 4th minus 5m to the 4th. So that's 2m to the 4th. Negative 2m squared plus 5m squared. So negative 2 plus 5 would be 3. So plus 3m squared. And then the negative 8 is the only number, so it'll just be minus 8. And there's my answer. So example 7, again, we have subtraction in between the sets of parentheses, so I want to distribute that subtraction sign. So I'm going to take away all the parentheses when I distribute, so negative 10x squared minus 3x plus 7 minus x squared minus minus 9. Minus minus turns into a plus. So now let's look for like terms. So I got a negative 10x squared minus x squared. So that's a negative 11x squared. Negative 3x. That's the only x in there. So it'll be minus 3x. It just stays the way it is. And then 7 plus 9, oops, which is 16, plus 16. And then our last example. Again, we have a subtraction sign in between the two parentheses. So I'm going to distribute this minus sign. So 2x squared minus 3x squared plus 1 minus x squared minus x minus 1. So I got 2x squared minus 3x squared minus x squared. So 2 minus 3 is negative 1. Negative 1 minus 1 is negative 2. So I have negative 2x squareds. I got a 1 minus 1. That turns into 0. So I'm not going to have a number in the answer. We still have that minus x. So our answer would be negative 2x squared minus x.